In this video, we're going to continue to discuss proving identities, but we're going to choose a different method. This method, we're going to either break a fraction up into separate fractions and simplify, or if they're already different fractions, you can combine the fractions and simplify. So in the first example, I want to prove that 1 minus sine theta over cosine theta is equal to secant theta minus tangent theta. Now, because in this example, I'm trying to show you how to use fractions to either break them apart or combine them to prove identities, I'm going to choose to work with the left-hand side. And I'm trying to show that it equals this side. It's already written as one fraction, so I'm going to show you how you can split this up into two different fractions. So I'm going to rewrite 1 minus sine theta over cosine theta as two separate fractions. I'm going to write it as 1 over cosine theta minus sine theta over cosine theta. So my denominators are the same still, and they should be. Okay, and I'm just going to take the numerator and split it up. So I have 1 over cosine theta minus sinus theta over cosine theta. And I want to show that that's equal to secant theta minus tangent theta. Well, using my knowledge of the fundamental identities, I know that 1 over cosine theta is equal to secant, which is what we're trying to get to. I'm trying to prove that these are equal to secant theta and tangent theta. So I'm going to rewrite 1 over cosine theta as secant theta. That's one of our reciprocal identities. Minus, and I know that sine theta over cosine theta, that's one of our quotient identities. I know that that's equal to tangent theta. So I just showed that both sides of the equal sign are the same. So we proved this identity by taking one fraction and splitting it into two fractions and then simplifying it. Okay, for example 2, I'm going to show you how you can combine fractions, simplify, and use that method to prove an identity. So if you notice, we always want to work with one side. Here's the more complicated side, and I want to show you how to combine fractions and simplify them. So I'm going to start with the left-hand side. I am going to write cotangent theta over 1. So I'm trying to show that cotangent theta over 1 plus sine theta over 1 plus cosine is equal to cosecant. Now, in order to add two fractions together and combine it as one, I need to find a common denominator. So what I'm going to do, I'm going to use 1 plus cosine theta as my common denominator, and I'm going to multiply the top and the bottom of our first fraction here by 1 plus cosine theta to create a common denominator. So on the top, I have 1 plus cosine theta times cotangent theta all over 1 plus cosine theta. So there's my first fraction written with the common denominator. I don't have to do anything to the second fraction. It already has my common denominator. And I'm trying to show that this is equal to cosecant theta. Now, I have a common denominator, so I can combine these together as one fraction. All over 1 plus cosine theta, and I want to show that that's equal to cosecant theta. All right, now, using my algebra skills, I'm going to distribute that cotangent theta. So I have 1 plus cosine theta times cotangent theta. So that's going to give me cotangent theta plus cosine theta times cotangent theta plus sine theta all over 1 plus cosine theta, and I'm still trying to show that this is equal to cosecant theta. So this one's a little bit lengthy, but not hard, just a little bit more lengthy. Now what I want to do is, it doesn't look like I can go much further from here by combining like terms or anything like that. So I'm going to try mixing methods here, and I'm going to add in the method of trying to change everything into sines and cosines. So I'm going to rewrite cotangent as cosine theta over sine theta plus cosine theta over 1 times cosine theta over sine. Okay, so I still have sine left. So I'll write that as sine theta over 1. And then I still have this all over 1 plus cosine theta. A little messy. We just got to take our time. Now, I want to maybe try to combine the fractions on the top. So they all have a common denominator of sine theta except for this last fraction here. So I'm going to multiply the top and the bottom here by sine theta. That way I have cosine theta over sine theta plus cosine squared theta over sine theta plus sine squared theta over sine theta all over 1 plus cosine theta. And I'm trying to show that that's equal to cosecant theta. Now, another thing I noticed here when I made a common denominator in the top is that right here, this piece right here, I have cosine squared theta plus sine squared theta. That is equal to 1. So I'm going to rewrite this as cosine theta over sine theta plus 1 over sine theta. That's all over 1 plus cosine theta, and I'm trying to show that that's equal to cosecant theta. Okay, next page. So this is what we have so far. Cosine theta over sine theta plus 1 over sine theta all over 1 plus cosine theta is equal to cosecant theta. That's what we're trying to show. Now, when I combine that top fraction, that's one thing I could do here. But what I notice is that I have in both of these 1 over sine theta. I'm going to factor that out. So that leaves me with cosine theta plus 1. So I'm going to pull out the 1 over cosine theta, and then I still have this all over 1 plus cosine theta. And I'm trying to show that that equals to cosecant theta. Now, on the top and the bottom, I both have 1 plus cosine theta. The order doesn't matter because this is addition. If it was subtraction, it would matter, but since it's addition, the order doesn't matter. So I'm going to cross those off, and I'm left with 1 over sine theta is equal to cosecant theta. And I know 1 over sine theta is a reciprocal identity that's equal to cosecant theta. So this one was a little bit longer and there were more steps involved. And sometimes when you try these, you'll have to stop halfway, try something else if it doesn't look like you're getting where you need to go. These take a lot of practice, and like I said, sometimes even myself, I have to go back and try a different method. But here's just one example of how you can incorporate different examples. But what we did was we started off by trying to combine two fractions into one and then try to simplify it from there.